Hello, welcome to an explanation of the observable example scripts and scenes. So let's start off with the observable bool. So an observable is simply a script contained on a game object which contains a value, and it contains a Unity event called value changed. And so anytime the main value is changed, this event will fire, and the listeners will react in return. So, a common theme among the observable bool, float, and transform scenes are we simply update a text component to display the value of the observable. And this is done using entirely one script for all observables. You can see here, if we go. So for every type, there will need to be a observable script created to support it. So we have like an observable bool, an observable float, and an observable transform. All pertaining to the value that is within their class name. You can extend this to whatever class you would like. You can use custom classes, you can use mono behaviors, you can use virtually anything. Preferably it would need to be serialized. Otherwise you're not going to get as rich of an experience within the Unity editor. However, the functionality will still work. So here we have the observable bool scene. We have our observable bool component. We have its value. See, we can see it, change it, and then we have fire event on start. So by default, since this is event-based and it's observable, by default, a listener, like the text component, will not automatically be set itself to the observable's value. So therefore, an easy solution to that is this fire event on start bool. It'll just fire the value changed event. The listener will listen and react accordingly. So when we go here, we can see right here this new text. That is the value displayer. And when observable bool changes, it will set the text component's text to that observable bool value. So since fire on start is enabled, we will see it be set to false, which is true. Now, unfortunately, due to the way serialization works in Unity, if you're in play mode and you toggle this button, nothing will happen. Fortunately, I've put simple context menu options that will work properly within the Unity editor. So we can see here, value, that, toggle, true, and we can see it's true here as well. And then it's set to false. And then seeing UI components, which basically call those same exact context menus, toggle, set to true, set to false. Works really well. The main advantage of this is performance and code and project cleanliness. This observable bool can mean anything. So it could mean, is the player running? Is the player eating? Is he sitting? Is he attacking? Is he casting a spell? And it gives you that flexibility across code bases, across scenes, across projects to develop a clean solution for your project. So that's observable bool. We can see here observable float. Basically the same thing. We have an observable float. We got its value. Got the fire event on start. Value changed. And we can see again, same principle, same script. And so if we enter the scene, the value is currently 0. The text object will update. And then observable float also has some helper context menus options, like add 1,000, subtract 100, add 100, add 1,000. And then we've got observable transform. So same thing, except this time we're dealing with a reference type. Still works fine, still functions properly. So if we just go ahead here and we drag in main camera as the value, and we fire event on start, and then press play, it will give us the information about the main camera. So again, this one's more just for testing and showcase purposes. You can just set the value to a random transform within the scene. So here it grabs the horizontal layout group, value displayer, and you can do it in the game itself as well. Pretty neat. Again, the important thing here is it's all event based. So there is no updates happening, which frees up a lot of performance. And then we also have loading and saving functionality. So here I have the 3 types. I have a float, a boolean, and a transform observable, which are all right here. And there is a helpful prefab or set of prefabs. What you would want to use is the observable file complete variant. This will give you complete file loading and saving for an observable value. And all you would need to do is set the name of the file you would like, and then for this example, on the save button we reference the observable file controller saver. So when we press that save button, we would like to save all 3 of those observable values in their own separate files. So like this one saves the health, this one saves is running, and this one saves the custom class, or it's a custom class. So yeah, showcasing the custom class here. So if we go here, press play, and yes, correct. So current target, yes. So let's go ahead and set this to a random in the scene. Let's go ahead and add 1 and then 10. And then for is running, let's just maybe toggle it to true. And then we also have my custom class. So let's go ahead and give it Mr. Jenkins. And then my float value, let's set that to 55. So in this scene, just don't get confused. I have the 3 observables which display the value, and then my custom class does not display a value, since it would display the object itself, my custom class, as opposed to its values. So that's why there's no value displayer for it. However, loading and saving functionality does exist. So again, here we're saving. So if we go ahead and press save. So unfortunately as well, notice how there's only 3 observables being saved, but I have 4 up here. So unfortunately, reference types like transform, mono behavior, game object, etc. are not supported. That's a Unity centric problem. That's nothing to do with this code base. References are really only meant to be saved or set during playtime. As you know, you'd be able to save a transform that exists during playtime and doesn't exist at the end of playtime and upon restarting. So it makes sense that it's not supported. So if you even try to support it, I throw an error telling you this value type is not supported to save. From my understanding, that's not a limiting problem. That's just the way Unity works. So if we go here, and we press the save button, and then we go to observable file. We have 2 options here. We have reveal in Finder and delete file. So let's go ahead and reveal in Finder. We'll open up our file, and you can see we have health.dat is running.dat, my custom class.dat. So unfortunately, these file types really aren't readable. They're serialized. You can't really understand them, as you can see. However, fortunately for us, we got a system that works really well and reliably for us to read, process, save information. So if we go back in play mode, we load on start. We initiate the loading on the start. So those values we had set previously get loaded back in. And again, as you can see here, current target is null. It's because we did not save that one. However, my custom class as well, we got Mr. Jenkins back, and 55. Let's go ahead and exit play mode so that we can see the custom class gets cleared out. Perfect. So we got one more example scene to go through real quick, very similarly. So you can either use a save button, you can use whatever method you want. The point here is to showcase you can use whatever method you want, whether it be any of these or whenever is ideal for your game to save information. So here, instead of pressing on a button, akin to something like Final Fantasy VII, where you reach a save point and you save at that point, this is when a value is changed. The value gets saved. So you can see here we have a new listener, which saves the observable when the value is changed. And again, just to reaffirm the idea, you can't change the value directly within the inspector. That's a Unity serialization issue. There's no easy, clear-cut solution to fix that. So you have to use these helper methods. So let's just do things up real quick. I'm just simply setting the text values. Something happened somewhere along the way, which reset the text components, which is fine. We'll just do that really, really quick. Perfect. So health, we set it to -1,000. It didn't update because the value was null. And again, we're not setting anything in updates, we're only setting things on a value change. So let's go ahead and just simply subtract another 1,000. We see -2,000. Is running. Let's go ahead and set that. Toggle, true. Current target, again, not getting set because it doesn't save. Now the interesting thing here is my custom class will not get updated because, again, several problems here. We are changing values in the inspector. Again, therefore, there's no way to run that. I can create context menus, however, that actually doesn't solve our problem with a custom class like this, because it's only when the value object is changed, not any of its values. So in this case, if you needed that functionality, you would actually do what's like here with health and is running. You would split them out of a custom class and have them as observable fields themselves. So to showcase that, we see my custom class, there was nothing to save it because the value didn't change. So you would need to tie that to something else. You could make like a staging observable my custom class to where you set that to another observable my class, and when that gets set, you can save it. Very flexible, hopefully easy to understand. So if we exit play mode and we return, we'll see health and is running get updated to their previous values. Unfortunately, can't fix this in post. Sorry about that. Let's go ahead and press play. So we see -2,000 in true. And then, as I stated earlier, my custom class doesn't get updated because, again, it's only when the object value gets updated, not when its field's properties get updated. Try to think of it as for a transform component itself. Let's assume it is savable. So for instance, if I were to have made its position on the x-axis 500, that would not trigger a value changed event. It would just simply change the x position. So that's that. That's a showcase of the system. There's a bunch more in the pipeline. Other projects are already utilizing this and are fleshing it out more and more. It's a very strong, flexible, clean solution that allows virtually no limitations. It's up to you, the developer. It allows clean code. I've been able to make entirely basically a complete old school RuneScape experience system using a series of observable floats and something that is in the pipeline called float calculation components. So the system can be used for anything. So I would appreciate any feedback, any ideas, concerns. See you in the next video.